Assalamu alaikum friends. Today we are going to study uses of electromagnets. Electromagnets are used in electric bell, telephone receiver, simple magnetic relay, circuit breaker, red switches, cranes, tape recorder, magnetic trains and many other devices. The functions of some of them are described below. Magnetic relay. This is a type of switch which works with an electromagnet. It is an input circuit which works with a low current for safety purpose. When it is turned on, it activates another circuits which work with a high current. The input circuit supplies a small current to the electromagnet. It attracts the iron armature which is pivoted. The other end of armature moves up and pushes all the metal contacts to join together, which turn the high current circuit on. Circuit breaker. A circuit breaker is designed to pass maximum current through it safely. If the current becomes excessive, it switches off the other circuit. Thus, electric appliances are protected from burning. As shown inside a circuit breaker, the current flows along a copper strip through the iron armature and coils of electromagnet. The electromagnet attracts the armature. If the current is large enough, the armature is detached from the copper strip and the circuit breaks. Telephone receiver. There is an iron diaphragm in the receiver under which an electromagnet is placed. The microphone or the telephone handset on the other side sends varying electric current in accordance with the sound signals. When the varying current passes through the coil of receiver on this side, it causes variation in the force of electromagnet. As a result, the diaphragm over it moves back and forth to produce sound. A wonderful use of electromagnets can be seen in maglev trains. The maglev stands for magnetically levitated train. A maglev uses force that arises from induced magnetism to levitate or float a few centimeters above the guideway. That is why it does not need wheels and faces no friction. In Japan, it is known as bullet train that can run up to speed of 400 km per hour. As described above, magnetic levitative and only lifts the train and does not move it forward. To push the train forward, propulsion electromagnets are installed along a guideway and train. The push and pull of these magnets move the train forward. Electromagnetic cranes. Huge electromagnets are used in cranes as steelworks and on ships. They are so powerful as they can lift iron and steel objects such as cars, as shown. After moving the heavy objects to a required position, and the objects are released by just switching off the current of the electromagnet. Domain theory of magnetism. It is observed that magnetic field of a bar magnet is like the field produced by a solenoid long coil of wire carrying current. Suggests that all magnetic effects are due to moving charges. In case of solenoid, charges are moving in the wire. The motion responsible for the magnetism in magnet is due to electrons within the atoms of material. We know that an electron is a charged particle. Also, each electron is an atom is revolving about the nucleus at the same time. It is spinning about an axis through it. The rotation and spin both give rise to a magnetic field. Since there are many electrons in an atom, their rotations and spins may be so oriented to strengthen the magnetic effects mutually or to cancel the effects of one another. If an atom has some resultant magnetic field, it behaves like a tiny magnet. It is called a magnetic dipole. Paramagnetic materials. If the orbital and spin axes of the electrons in an atom are so oriented that their fields support one another and the atom behaves like a tiny magnet, and materials with such atoms are called paramagnetic materials such as aluminium and lithium. Diamagnetic materials. Magnetic field produced by both orbital and spin motions of the electrons in an atom may add up to zero. In this case, the atom has no resultant field. The materials with such atoms are called diamagnetic materials. Some of their examples are copper, bismuth, water, etc. Ferromagnetic materials. There are some solid substances such as iron, steel, nickel, cobalt, etc. in which cancellation of any type do not occur for large groups of neighboring atoms of the order of 10 raised to power 16 because they have electron spins that are naturally aligned parallel to each other. These are known as ferromagnetic materials. The group of atoms in which a type of material from a region of about 0.1 mm size that is highly magnetized, this region is called a magnetic domain. Each domain behaves a small magnet within its own north and south poles. Alignment of domains. The domains in a ferromagnetic materials are randomly oriented. The magnetic fields of domain cancel each other, so the material does not display any magnetism. However, an unmagnetized piece of iron can be magnetized by placing it in an external external magnetic field provided by permanent magnet or electromagnet. The external magnetic field penetrates the unmagnetized iron and induces magnetism in it by causing two effects on the domains.